Hello guys, today we'll be talking about blockchain and smart contracts, which will be a beginner's level introduction, and we would be covering what's blockchain, how blockchain can be intuitively understood, and then we would move on to smart contracts, which are an integral part of the blockchain. So let's get started. So basically assume that smart contract, the way we have our contracts, and we have got some information, and those contracts are signed by people. So in the similar fashion, when we say these contract has to be stored somewhere and this information has to be stored somewhere, so blockchain is the place where we store this. So what's blockchain? Blockchain is basically a digital ledger of transactions. So what it does is, simply said, it's just it manages all the transactions. So when we say transactions, we mean that the date, time of the transaction, what was done. All right, so this is when, this is then what was done. Like for example, funds was transferred, or minting was done, whatever the operation was done. All right, and then who were the parties involved. So in a transaction there is a from, and then there is a to. So this operation was done by someone, and then maybe the operation was performed for someone. So these are the things which are kind of stored in the blockchain. And of course there are some gas fees involved, the fees are involved, then of course there is balances or amounts also involved. So there are several other attributes. Of course there is a unique address of a transaction, which is very necessary to identify that particular transaction. So a digital ledger of transactions. So that's what in a very basic sense what's blockchain. And one main thing is that these transactions are duplicated, distributed, and shared among the nodes of a computer network. So that's how the blockchain is a very powerful concept. So these particular transactions are duplicated, shared, distributed, and shared, so that there is no loss of information, there is no centralized information or server is required, since you must have heard it's decentralized. That's where this decentralized thing. So decentralized, where the transactions are duplicated, distributed, and shared among the nodes of a computer network. So this is how assume that this particular network and all the information stored. So and then what happens is that mainly it stores three kinds of information, which is the transaction data, which we've already discussed, that this particular transaction. And like I said, there is a address or a unique identifier of a transaction, so that's a hash. All right, and since that a transaction is a sequential process, so one thing happens, then other thing happens, and then the third thing happens, and then these are called the transactions. So each and every individual transaction has a hash of its own, and then what it does is it also stores the hash of the previous block, as illustrated here, that for example, this block should know that it's part of this chain, this particular transaction sequence. And of course this transaction should have a track of its previous transaction. So again, each transaction has its own hash and the previous block's hash. So that's previous, that's current, and itself it contains the data, transaction data, which might be, as I said, amount, the parties involved, and the operation, what operation was done. By operation I mean minting or whatever, funds transfer. So so stuff like that. So these are the basics, and that's where blockchain, these are the principles on which blockchain works. So when we say hashes or addresses, so these hashes or addresses are essential part in itself. How? So since a hash is a unique code that identifies a block and all its content, so it's like an address. If we want to just know about a particular transaction, we need to pass that address, and that's it, and we would get all the information regarding it. And then it's also useful because if we want to track the changes, and if we want to see that this particular transaction is of which sequence, and whatever is going on, or this transaction belongs to maybe some contract. So all things are tracked by this hash. The presence of the hash of a previous block in the next block effectively creates a chain. So like I mentioned here, that having the information of previous block effectively helps in managing this chain. So it becomes a chain. And why we have done this? Because this particular block has the information of previous block, so it's kind of a chain, and the technique makes this a blockchain. So that's where hashes are very crucial. So now let's talk about the smart contract. So this is the architecture. The blockchain is there for the operations to perform, for things to be, functions to be called, but this is the block, just block. And how we are gonna use this blockchain, and how we can basically manage the states, the information, the data. So that's where smart contracts comes in. Smart contracts are digital contracts stored on a blockchain that is automatically executed when predetermined terms and conditions are met. So this is a very beautiful statement, that assume that in for example real life we have got these physical paper contracts, and for example we do sign a contract, but there is, if you must have seen, there is a governing body. For example, this might be of some government or by some law or somewhere which is centralized. All right, it is that particular paper contract is, in the real life, normal life, paper contract are centralized, not decentralized. And then there are some issues regarding the centralized contracts. First, we need to trust that entity or that centralized authority. For example, if it's some sort of a government document, so we need to trust the government that if this contract, whatever the conditions are met. So for example, funds are need to be transferred, or whatever the conditions are. So the contract has to be followed. So we need to rely on that entity, or that centralized body. But in blockchain that's not the case. Since it's decentralized, whatever two parties agrees upon, and whatever the code is there, whenever the conditions are met, the code is executed and the transaction is done. So for example, we purchase some property, and for example we have this smart contract, and we have this condition that after, for example, 3 months, after the 3 months the property has to be transferred on this particular address, which is a particular person's MetaMask wallet. I would be discussing about what's MetaMask, but assume for now this is a wallet, which is an identity of a person. So for example, if I want to do a transaction on the blockchain, via some blockchain, so I would require this particular wallet, and this wallet has a unique address which is unique to me, and basically identifies that which person is doing the transaction. So coming back to the point, so the blockchain has this particular smart contract, and in the example, for example, after 3 months or whatever the case, if the funds are transferred, if the transaction is done, so the a particular maybe a token or something would be transferred. So there are several scenarios which we'll be discussing in the subsequent phases when we'll be actually implementing a smart contract. So, but for now, this is the case that it's the best part is that it's automatically executed. We don't have to wait. We don't have to rely on some centralized body to comply to this smart contract. So that's where just to solve the issues of centralized bodies and trust issues, that's where decentralized and trustless systems are. That's why they are being adopted these days. So, and what happens is that they typically are used to automate the execution of an agreement without any intermediary involvement. So there are no intermediate parties involved which would enforce the contract. For example, when the conditions are met, automatically all the terms and conditions which were agreed upon would just execute. There is no need for waiting or trusting someone that going somewhere and then asking that this work is done or something. It executes. So, and then this includes releasing funds to the appropriate parties, registering a vehicle, sending notifications, issuing a tickets. These are the examples that whenever a contract is met and some things are done, so when these conditions are met, So maybe funds need to be transferred, or maybe some vehicle, for example, in this case, or for example, NFTs are tokens. So tokens might be, being transferred, anything regarding this particular contract. So yeah, it's executed automatically. And then to establish the terms, participant must determine how transactions and their data are represented on the blockchain. So, these, of course, whenever there is a contract, this contract is between two parties. So, for example, these two parties need to agree that, okay, fine, these are the conditions and this is the contract. And when these conditions are met, for example, the funds would be transferred, or whatever be the case. So that's where, the fund transferring happens. And so first of all, there has to be an agreement on the conditions on the basis of which this smart contract is built. And when we say the smart contract is built, what we mean is that, it's programmed by the developer. So what happens is that, this particular contract is programmed and then deployed on the chain, deployed on this is, for example, blockchain. So this is the beauty of it. Once it's there, it can't be changed. This smart contract, when it's deployed on the blockchain, now blockchain has it, and it's part of a transaction. When this deployment goes live, there is an address associated with it. So all things are documented in the sense that it can't be changed. It's there on the chain. So this is what happens, and that's why all the things are included in the contract during the time of the agreement and before the deployment. So we need to make sure of that. After deployment, the contract can't be changed and it would be executed as per the programming or as per the conditions. So basically, as per the definitions and what we are discussing right now, the smart contracts provide the infrastructure for a DeFi industry. So basically, it's decentralized finance. So it's often termed as DeFi or DeFi, whatever. So decentralized finance. This is a huge, it's a booming industry these days because it's all about finance, right? And for example, insurance companies are there, banks are there. All these companies are centralized, and we need to trust them. That for example, insurance company, if something bad happens to us, then they should disperse the particular amount or whatever the contract was. So we need to trust them. But that's where decentralized finance, this field comes in. That it's decentralized. We don't have to trust. We just do we do according to the contract, and as per the contract, if particular condition is met, so the finances or the funds are transferred. So some of the properties of smart contracts and smart contracts which are deployed on the blockchain. So some of the properties are that speed, efficiency, and accuracy. So of course, in finance and operations like this, these are some of the very desirable features. So once condition is met, so when condition we mean by the agreement between the two parties. So when the condition is met, the contract is executed immediately, which automates the process without paperwork. There is no approval required. There is no whole process, and it won't take n number of days. It's like whenever the condition is met, transaction will be done. So that's the beauty of this whole process. And these all things promote trust and transparency, and that's why this decentralized concept is basically so decentralized. And like I said, decentralized finance. So that's why these industries booming, and these concepts are evolving very, very fast. So because there is no third party involved, that's the best part of it. There is no need to question whether information has been altered for personal benefits. So for example, if there is an insurance company might do some twist and turns and might not agree with the contract, or something happens. So there is no biasness, there is no conflict of interest involved. Whatever the agreement was, whenever the conditions are met, the transaction happens, and there is no third party involved which would be deciding whether the contract is met or not. So yeah, that's one of the things. Then there is security, a huge part, blockchain transaction. And before we come to security, the transparency is So we can see all the transactions on the blockchain, and we discuss about the transactions. So that's totally transparent. We are not, in the dark regarding, again, trusting someone that, whether our work was done or the transaction was done, or any of such things. And these are all due to the fact that blockchain has got features for security. And of course, the smart contracts in blockchain, we need to program it in a way so that the security is, these things are ensured. So blockchain transaction records are encrypted, which makes them very hard to hack. Of course, we can't say anything is unhackable or something, but yeah, since these hashes and these transaction records are encrypted, so it's very hard to hack these things. Savings. So smart contracts remove the need of intermediaries to handle transactions. By extension, their associated time delays and fees. So this is one more byproduct of these transactions which we have been talking about, that since there is no third party involved, so there is no fees involved, there is no, for example, there is no third party for the transactions, or for making both the parties follow the contract. So there is no third party, so there are no fees involved, there are no time delays involved. So that's a byproduct. So having said that, regarding the smart contract, these are the principles on which smart contract work. But like I said, the smart contract have to be programmed by a developer. So that's where we need to move on, and that's where programming occurs. So we will be discussing about this further on. So how smart contracts, so we do now understand that smart contracts are basically coded, and that smart contract is deployed on the chain so that the smart contract can be executed, or those functions may be executed. So when I say such things, what do I mean? So now let's see programmatically what smart contracts do. So smart contracts are used for managing the state or data of particular agreements. For example, something happened, so the contract is used to update the blockchain, and then there is a transaction. So whenever we'll call it contract, smart contract, so we do get a transaction. And of course there is a fees associated, the gas fees, which you must have heard. So a gas fees is associated with the transaction depending on the chain. Of course, some of the chains pretty expensive regarding the gas fees, but others also, some of them are free also. So yeah, but the point is that each and every smart contract, when it's deployed, and when we need to perform some operation, we need to call the function and use the smart contract. We need to call the function within the smart contract so that we may be able to read or write any state or data. Okay, so now, like I said, code functions to perform some functionality. We need to code it. We need to make functions inside the smart contract which are callable. And of course, how that smart contract, after deployment, it's identified by a unique public address, and that's a hash. And we can also track the transactions associated with that particular smart contract. And then this particular smart contract, of course, when I'm saying it's deployed, so it has got its own balance. What happens is that at times there are some use cases when the balance is initially transferred to the smart contract, and then when the conditions are met, so for example, it's one party is here and the amount is transferred to the smart contract, and when the conditions are met, this particular amount would be transferred to the other party. So whatever the work, for example, a work has to be done, so that work is done, so this balance will be transferred to this. So in the meanwhile, this contract holds the balance. There is no third party, there is no centralized body to manage this. It's all on the chain, right? So, and then we can read and write data via functions. So when we say write data, we mean that we need to update the states. For example, tokens are minted, and the funds needs to be transferred. So this is all, these are operations. And there are several programming languages in which we can just write this code. Solidity is used for Ethereum and such contracts, Rust, JavaScript, Go language, C++, etc. So there are several languages in which smart contracts are written. So now this was the kind of a overview of what are blockchains and what are smart contracts. and we discussed about the blockchain being, digital ledger, and the main part is duplicated. So these transactions are duplicated, distributed, and shared so that it's redundant, it's secured. There is no fear of loss of information since it's distributed and it's not centralized. And then transaction data hash and previous hash is stored, so that what makes it a chain actually. And then we discussed about the hashes, and then we jumped on to smart contracts, and we described that how smart contract differs from the actual paper contract which we have. And then we talked about the some of the examples, and then how automatically a transaction is executed whenever the conditions are met of a particular contract. And then we jumped on to discussing about the decentralized finance of applications, and these were the some of the features of smart contract. Trust and transparency being the main, and then security, savings, that we don't have to pay any fees to third party. Time, there are no time delays. And then we discussed about that, when we said that the smart contracts are programmed, so what it means and how it's done. So that's it for now. Thanks for watching.